Hello and welcome to Wednesday's edition of Cracking the Cryptic, and on screen we have a puzzle by Diana Voyer, who compiles under the pseudonym Bismuth. And Diana sent me an email just the other day pointing me in the direction of this puzzle and its rating on Logic Masters Germany, which stands at a staggering 98%. So obviously I want to have a go at it. Also, the other reason I want to have a go at it is I love these puzzles that combine sort of a classic pencil puzzle with Sudoku. I think that there's just so much opportunity for beautiful new logic, and I think this puzzle will be no exception to that rule. I'll go through the rules in a moment. I just want to give a quick shout out. If you are a patron of the channel on Patreon, obviously big thank you for that. But our monthly reward video is now released, so that's the solve of the Queen Sudoku that we put out as July's reward puzzle earlier in the month. Yeah, and we've got something quite good coming up for patrons in the coming days as well, so do keep an eye out for any notifications that you get from Patreon. Now, what are the rules of this puzzle? It's called Poison Bagel. The reason will become apparent. We've got normal Sudoku rules apply. The circles in the grid are the centres of rotationally symmetric galaxies. Every cell in the grid is part of a galaxy, and digits may not repeat in a galaxy. The number by each circle represents the sum of the digits in that galaxy, and galaxies treat the grid as a torus. That is, rows 1 and 9 are adjacent and columns 1 and 9 are adjacent. So here we have the sort of final form of the spiral galaxy puzzle. We've done a few of these on the channel where it's been combined with Sudoku, but we've never done one, at least I don't think we've ever done one, which has insisted that the entire grid is divided into galaxies, and we've not done one that uses the toroidal property that's possible in Sudoku puzzles either. So let's just go through what all this means. What's a spiral galaxy? Well, it means if we're looking at this 21 cage, for example, and we decide that this cell has to be part of the spiral galaxy that's connected with this circle, then we'd also have to include this cell as well, because we must ensure that this galaxy, once we've finished creating it, is rotationally symmetric around its dot. Now, where this is going to get seriously complicated on this puzzle is that we have to be able to view the fact that this cell rotated around this dot on the perimeter is that cell up there, because the grid, basically you can view it as I don't know if you like Klein bottles or Mobius strips, but yeah, basically the grid has only one side, and it's like this top bit is connected to the bottom bit round the corner. So this is going to lead to some mind-bending logic, no doubt, but all the better for that. This should be a lot of fun. Do have a go at the puzzle first, of course, and the way to play it is to click the link under the video, and with that I get to have a go. So let's get cracking. Now probably, oh no, actually I was about to say probably what I have to do is to start creating galaxies, but actually this dot here is at the centre of a domino. So when you have a dot at the centre of a domino, you know the galaxy associated with the dot must be an even number of digits large, because if we, for example, try and put that cell into this galaxy, then in order to keep this rotationally symmetric around this dot, that cell would also have to go in. So you can see here that a 4-cell galaxy for a sum of 6 is absolutely impossible, given you can't repeat a digit. So this is definitely a 2-cell galaxy, and it can't include a 4. So this must be 1 and 5. And that actually allows us to place a digit, doesn't it? Because this domino here must also be an even number of cells. It can't possibly be 4 cells, it must be a 2-cell galaxy, and this top cell can't be a 1, 3 or a 4, because there are already a 1, 3 and 4 in the row, so that's got to be a 2. This is a 3. Now the 9, yeah, now the 9's done as well. Again, the dot is in the domino, it's at the centre of the domino, so we know this is either a 2-cell or a 4-cell cage. Well, can it be a 4-cell cage? Well, no, it can't, because 1 plus 2 plus 3 plus 4 add to 10, not 9. I mean, it could be a 6-cell cage, an 8-cell cage. That they are obviously broken. But 4 is also broken. So this is a 2-cell 9 cage, which means it can't be 2, 7, 3, 6 or 4, 5. It is 1 and 8. There's got to be a 1 and a 3 up there by Sudoku. That's these 1s and these 3s interacting. Oh, that can't be a 1. We looked at 44 cages the other day in a different video. I can't remember which one that was, but the key to remember is, how do you build a cage or a galaxy that sums to 44? It must contain 8 cells, and we know that because all of the digits 1 to 9, if we add all of them up, we get 45. So in order to create a galaxy that adds to 44, we've got to use all of the 8 digits apart from the 1. So given that these 2 cells are definitely part of the 44 galaxy, there's no way that can be a 1. There's another 2-cell 5 galaxy there, look. Maybe I should start labelling some of these galaxies actually with colours. I'll make that one green. I'll make this one grey. The 26. Yeah, look, this 26 is bounded on its top and its bottom side. So how are we going to get... We can't make 2 cells add to 26, so we've got to start extending horizontally. Now that's interesting, so we can't keep going horizontally now, but maybe we could do that. So it's at least this number of cells. I'm not sure whether it goes further. The 14 though is now bounded on its top side and on its right hand side, so it can't extend in any direction. So the 14 is a 2-cell galaxy. The 12, actually one of the things that, this 12 is interesting. Let me just highlight it. The thing I was thinking about was this square. Have I broken this? See, this square can't be part of the 12 galaxy because the rotation would take it onto this 39. In fact, let's just pause for a moment to note the hideousness of this 39. Oh my goodness me. This 39 galaxy. Oh, I'm gonna be so bad at working out the rotations here. You can see that the dot means these 2 cells are definitely part of the 39 galaxy, but I mean, if it takes that square, what's the rotation of this square around this? It's that square up there. So these 2 squares are rotationally symmetric around this dot. Oh, good grief. I mean, yeah, this 39 is going to take some fathoming out. But the cell I was actually looking at was this one. And which galaxy can this be part of? Now, I think it can actually be part of this 10 galaxy, because the 10 galaxy has a dot at the top, which means it's definitely those 2 cells. Now, the only cell, or the only galaxy that can now get to this cell is the 10 galaxy. So it must go there, and that is okay, because of course you can make 10 in 4 cells if you use 1, 2, 3 and 4, which is what they must be. Oh, so that square's a 5 now, just doing a bit of Sudoku. So I guess the rest of the column is 6, 7, 8 and 9. Let's put that in. That can't be a 7 because it's in a 2-cell 14 cage. So that's either 6, 8 or 5. The 19 cage now can't take this square. Well, it can't take this square because the rotation would take it there. So this must go vertically. So it must be at least these 3 squares. But it could go further. It could, yeah, it could take the 2 and then that one. It's quite bizarre to think that that shape is symmetrical, but it is. 45 Galaxy, that's got to take all 9 cells. Sorry about this, let me just stare at this. So what takes that square then? Oh, this is, so this, oh, this is what we are going to have to think about, this 39 Galaxy. Oh, this is interesting, isn't it? This is actually, we're going to have to think about it, and we're going to have to use the 14 Galaxy to think about it up here, because this is part of a galaxy. Let's think about this. So the 39, it has to be, it's an even number of cells because the dot is in the middle, is sort of on the line. But it could be 6 or 8 cells, because if it's 6 cells, we'd need the missing 3 cells to add up to 6, and that is possible if they're 1, 2 and 3. If it's 8 cells, it would just be missing the digit 6, because 45 minus 39 is 6, obviously. So far we've only placed 2 of the digits, so it's got to have at least 4 more digits. But no, I don't think another galaxy can get to this square. The only galaxy that could... No, I mean the 45 can't, the 12, this 12 can't, it would then be too large. The 10... No, it's the reflection of this square around this square, bizarrely enough, is this square, which is part of the 9 galaxy. So this square has to be part of the 39 galaxy, and the rotation of this square around this point is that square up there. Good grief. So if the 39 galaxy took this square as well, that would be that square, which it can't take. So this square is part of a different... Is it part of the 26 then? Or it could be part of the 10. Whoa. Okay. Not sure. Not sure. It's certainly very interesting though, isn't it? I mean, oh, the 19 galaxy can't take either of those squares, so it must extend vertically, and therefore it picks up that cell, which might be interesting. The 21 galaxy has to go vertical because of this one, so it must take at least those 3 squares. Let's make those purple as well. And the 21 then hits this square, so this 21 will make that come across there like this. And the 21 obviously has to go further. The question is, how does it go further? We've also got a 35 here. Maybe this is where we should spend some time. Let me just colour this in some colour that I haven't used yet. So this can't take this square because the rotation would take it there. 35 has got to be an even number of squares because of the domino position. So it's got to be 6 exactly, because if it was 8 it would be missing 1 digit that would be a 10, and that doesn't exist. So it's 6 cells. So it's got to take this square. It just has to, because it can take that one, but even with that one it's obviously only getting to 4 once it rotates to here. So it always has to take this square, which rotates to there. So those 2 squares are definitely in the 35. That isolates this square, so that's in the 35, and that completes the 35. So the 35, and that now bounds the 22 cage. This is mind-blowing. So, and now what's this? This could be part of either 21 cage. Look at that. But this square can't. This square. Oh, it could be part of the 14. Ah! But that square can't be part of the 14 and can't be part of the 35. In fact, this square could be part of the 22 as well. Oh my goodness me. This square though can't be part of the 22 and can't be part, so this has to be part of the 21. So the 21 shifts up to being 4 cells large. Could still be 6 cells, could still be those 2 squares, couldn't it? That is possible. You can make 21 with 6 different digits if you use 1, 2, 3, 4, 5 and 6. But this square now can't be part of the 21. Oh, but it could be part of the 14 again. Ah! Oh, but no, it can't because of this 12. Oh, good grief. So the 12 does poke into the bottom. Now the 12 is now the 12 is bounded, isn't it? It can't go anywhere. So the 12 is a 2-cell cage. The 17 cage now can't go right, so must go vertical and is then bounded. So that is the full extent of the 17 cage. The 14 cage now can't take this square because of that square. So this square has to be part of the 22, I think, which means that square is also part of the 22, and the 22 is now finished. The 44 is finished because the 44 must be 8 cells large. Now to the left of the dot there are only 4 cells that it can take, so it must take those 4 squares and rotate onto the rest of them like this. There's no 1. We place a 1 therefore. There's no 1 here, look, because there can't be a 1 in the 44 cage. Oh, so there's a 1 in the 21 cage, which means we must extend it. It can't be a 3-cell cage. It can only extend into those 2 positions. This is beautiful, isn't it? Now, now what on earth takes those 2 squares? Is it? Oh, it isn't, is it? Is it this 39 cage? This rotated onto this. This square. Oh, this square. Did I not mark this one in? I think I might not have done. This square. Oh no, I did. That's just the rotation of that. Oh, what's going on? Oh, I see. Oh my goodness. These 2 squares, the rotation of these 2 squares around this dot. Yep, you've guessed it. It's those 2 squares. Oh, that is very hard to see. I think it's correct though, isn't it? So you've got to dip 1 down off the grid and 1 up here. So yeah, it is those 2 squares. My goodness. And unfortunately I've made those red in the 10, so I need to change the colour of the 10 cage. I'll make the 10 cage green, and then I can make those 2 red to indicate they're part of the 39. And the 39, 1, 2, 3, 4, 5, 6, 7, 8. So it is an 8-cell. It is an 8-cell 39 cage, which means it's not got a 6 in it. And this square is lonely. And this square can't belong to the 26 anymore, so it must belong to the 10. So I'll make those grey. The 45, look, it's the only one we haven't done, and it's forced. It's perfect. This 2x2 region, reflect it around this dot, you get that 2x2 region. And that is what the final puzzle looks like. So that is the spiral galaxy. That 39 cage is completely balmy. Now, actually look, and this 39 cage doesn't contain a 6. So where does 6 go in box 7? This 6 rules it out of those squares. It can't be in the 39 cage, it can't be in the 12 cage, or we'd have repeated 6s. So the 6 lives in one of those squares. And that allows us to place a 6 here by Sudoku, because we can't put a 6 in the 39 cage, and it might not look like it, but these squares are part of the 39 cage. So 6 goes there. So 6 is now in this cage up here. It's in the 35 cage. Now the 35 cage, oh, that's actually important, I think, because the 35 cage is only 6 cells large, so it's missing 3 cells that sum to 10, but it's not missing 3, 4 or 6. So the only way you can make 3 digits add to 10, if you can't use 3, 4 and 6, is 7, 1 and 2. So where does 7 go in box 6? It can't go in the 35 cage. It must go there. And now we know the composition. These squares obviously have got to be 5, 6 and 9. And these two squares therefore have got to be 3 and 8, because we know the exact composition of the 35 cage. 5, this is not a 5. That's not a 7 or an 8 now. Oh, in fact this 7 is rather interesting, because we can use geometry again. 7 must be in one of those 3 squares in the 26 cage, and it can't repeat in the 21 cage, so it must be in one of those 2 positions, which is part of the 44 cage, so this can't be a 7. And in fact we can go further than this. Where does 8 go? 8, it looks like 8 can be in one of 3 places in box 5, but we can't put 8 here, because 8 plus 7 is 15. We'd have to make these 3 squares 1, 2 and 3 to add up to 6, and we can't. There's a 3 there already. So 8 joins the 7 and becomes a 7, 8 pair. And now look at this. In column 3, we've got a 7, 8 pair in the 44 cage. So these 2 squares must be a 6, 9 pair, which means these 2 squares are not 6 and 9, which means this one is an 8. Oh, this is gorgeous. 8, 7, that's a 6 now to complete the 14 cage. No 7 in those squares. The missing digits in row 5 are 6 and 9. This has to be a 6 or a 9, and can't be a 9 because that just breaks the cage total. This has got to be a 6. So these 2 have to add up to 5 without using 1, 6 or 3, 4. This has got to be a 2, 5 pair. There's a 2 at the top of the grid. It's just gorgeous. Absolutely lovely, this. Now, this means that's a 9, of course. So this becomes a 5, 6 pair, which fixes the 9, 6 there and there. So we need 2, 4 and 6 into this box, look, and there's a 6 here. So the 6 must live here, the 2 must live here, the 4 must live here, this must be a 9. And this is a 3, 4 pair. I think the logic's good there. Oh, maybe we could. Yes, we can. We can do some Sudoku on this weird 19 cage. 19 plus 5 is 24, plus 9 is 33. So to make 45 for the column, these 2 squares have to sum up to 12. Well, they've both got to be a maximum, therefore. That's a 4, that's an 8, that's a 7, that's a 3. The 5 cage now can't be 1 and 4, so it has to be 2 and 3. This 19 cage, those 2 squares have got to add up to 13 without using 6, 7 or 5, 8. So those are 4 and 9, which means these 2 squares are 1 and 8 to complete the column. Sorry about this, 1 second now. There's so many places we could actually look here. I'm just trying to spot whether there's an easy way of proceeding. I'm failing abjectly to spot anything useful. 8. So, oh, surely not. Yes, okay. Look at this 8. That is weird. This 8 locks an 8 into one of 3 positions in box 8. Now, ordinarily, you would just stop there. But now, this 45 cage now contains an 8 down here, so it can't contain another 8 up there. So that becomes a 1. This becomes an 8. And, oh, look at... Okay, so now that's got to be a 1 by Sudoku. This is crazy. So these 3 squares are now forced, I suppose. They've got to be 5, 7 and 8 in some order. So in our 45 cage now, we've not placed 3, 4 and 9. This square therefore has to be a 4 or a 9, I think. These two are 3, 4 or 9. Ooh, let's have a look at this 17 cage here is in the same column as 4 digits we've identified, which add up to 18. So 17 and 18 is 35. This square and this square have to add up to 10. Yes, so this can't be 4. This can't be 4 because that would put a 6 here, which would clash. So this is a 9. This is a 1. This is not 1 anymore. This is not 2. This is not 1. This 9 sees this 9, 4 pair, so let's fill that in. So surely this 10 is now fixed, because again, if we look along this row, it's really hard to scan this efficiently, at least for me. But we've got 10, 20, 37. These two squares have got to add up to 8, which means they have to be 3 and 5. It's the only combination that will work there. That places a 2 here, gives us a 7, 8 pair below. These have got to be 1, 2 and 7 to complete the 10 cage. 1, 2 and 7. Oh, we still can't figure out that 12 cage, look. Oh, but we can fill in this square, which of course is the last digit of this 44 cage. That's a 5 that's missing there. Let's have a look at the 21 cage. We've now got these two squares having to add to 12 without using 4, 8 or 5, 7. They are 3 and 9. That is resolvable. That means, I suppose once we got this 9 we could have... Okay. So now to complete row 3 of the grid, I need 2, 4 and 7. That one can't be 4. That one can't be 4, so this one's got to be 4. That one can't be 2 either, so 7, 2. We've now got 2 and 4 in this 22 cage, so these two squares have got to add up to 16. They've got to be 7 and 9. Can't resolve it yet, but that sounds useful to me. Neither of those squares can be 4 because there's a 4 in the box already. Wow, okay, it's still holding out. That can't be 1. Do I have to use this 39 cage again? There's no 6 here. There's no 6 there. Oh yeah, good grief. Yeah, there's no 6 in the 39 cage, so this can't be a 6. This can't be a 6 because it's part of the 12 two-cell cage, and you'd have to repeat the 6. This 6 rules out those, so there is a 6-8 pair in the 14 cage, which I thought would be more useful than it appears to be. That plonks an 8 into one of those two cells, which is part of the 39 cage. So now we can come down here and note there is no 8 in any of those squares. So the 8 must be in one of these two positions in box 9, which means this is an 8 and this is a 7. This is quite bananas, isn't it? Now, let's have a look here. We've got to place 4, 5 and 8 into this column. Given the 8's up here, this must be the 8. This must be a 4, 5 pair. So this 12 cage now, can we do this? 4, 5. We've still got to place 9 and 7. So if this was 9, this would be 3, and if this was 7, this would be 5. Both still seem to be possible. I'm sure I'm missing lots of things here, but I hope you'll excuse it. It's quite a challenging puzzle to solve live on the stream. 2, 3, 4, 5. These two squares then, is this where I'm meant to look? 5 and 6. Yeah, okay, so that fixes a 6 and a 5 there. That fixes a 5 and a 4 there. A 4 and a 3 here. That's lovely. That gives me the 2. Now, does that resolve everything or not? I feel like it must do, but I'm just not spotting how. This 12 cage now, that's got to be 3, 9. That is helpful. 9, 3, 4. That's got to be a 1. That gives me the 3 at the top. The 9, 7 gets resolved. Yeah, this looks better all of a sudden. This has got to be 1, 8. This square here can't be 1. 2, 5 and 7 there. Ah, still not resolved. Maybe there's a... This one can't be 2, this one can't be 7. This has got to be the 2, it's the only place the 2 can go in row 9. That does give me the 7 and the 5. This is a 5 now. That means that one's a 7, that's a 9. And we should be able to write this digit in, obviously, 3. These two squares again should be write-ins. They've got to be 4 and 7, which we can now do. Hopefully this 4 is going to help. What's the missing? Ah, this 5, sorry. The 5, the 6. The 6, the 8. The 8, the 1. The 2... and the 1 and the check, and that is how to solve that puzzle. That is a lovely, lovely puzzle. I hope you guys enjoyed it. Let me know in the comments, and we'll be back soon with another edition of Cracking the Cryptic.